Yeah, so Robert, do your screen share. Robert's here to share with us the story of Kart, a practical tool for versioning geospatial data.
Hi, everybody. One
Hello.
second.
Yeah.
I don't actually live in a castle. I'm in this huge Senate room in Glasgow University today as part of Phosphology UK.
A likely story. We know you have a castle.
Sorry, just rearranging my window. There we go. So yeah, my name's Rob. I'm from a company called Coordinates, and I'm here to talk about practical data versioning, particularly in PostGIS. And so I'll tell you a little bit about what Coordinates does. We're a geospatial data management platform. We make it easy for professional map wranglers to find and access their geospatial data and get on with their jobs. And that could be making decisions or building maps or creating models, developing applications, or 1,000 other things. And on the flip side, we help publishing of data, so government, science, commerce, organizations to surface valuable data out to the public or to their contractors or partners or staff. So I just want to think about what the version control tools we have in a modern software development environment and the expectations that we kind of have on a day-to-day basis. And so we actively work across multiple contexts and we switch between them. We have branches of work and we have features, we have maintenance things we need to do, and we can just all make those work at the same time. And we can take our commits and merge them into logical changes rather than just the stream of thought and fixes and other things that we do as we go along. And importantly, we can use things like pull requests and code reviews to collaborate and get feedback from our peers, both in our teams and across our teams and across companies and organizations. And we use things like continuous integration and testing to apply checks and standards to our code. And these are the kind of clever value adds, but the really basic stuff. We can always see who changed when and why and what. Well, we can certainly see what and when and why if the commit messages aren't complete rubbish. And all these things developers use every day, but just aren't practical to the people managing data about our world. And from talking to our users at Coordinates and customers and communities, we kind of really want to know these things, and they really want to be able to do these things too. So what are some opportunities for version control around data? We've been talking about reproducible science for quite a few years, and we kind of have code with Git and environment. We look at things like Docker and Conda and IPython notebooks, and we can kind of do some of the reproducible stuff there, and data sets are a problem there. And so maybe we can use version control to help some of that reproducibility to make sure that what we're looking at is exactly what a scientist was working with when they wrote their paper. And this all ties into data provenance and being able to actually validate that we're all on exactly the same page. Often as data practitioners, we're used to downloading data and consuming APIs, but going the other way is extremely rare, with OpenStreetMap being the obvious exception. But even then, when data sets get imported into OSM, there's almost never feedback or changes making it back to the origin of those data sets. We have customers who publish high-value authoritative data, and they get zero feedback. And it's a dream of theirs to receive actionable change suggestions from their users. We have different groups, we have different operating systems, we have different software ecosystems, and not even open source versus commercial, but CAD versus geo, web, science. Coordinate systems for survey data are different from those for small and large scale mapping, web mapping, geocoding. Why can't we have a data model that works between these ecosystems? And why can't our version control system use best practices and take some of that plumbing burden for users? It won't necessarily do everything for everybody, but it can lift away a lot of that plumbing work. And synchronizing and transferring data between systems should be easy and reliable and fast. No more paging through hundreds of WFS requests to get a new copy and trying to compare it to what changed since last month. We've had linear versioning at coordinates internally for a long time, implemented in Postgres. And some of our customers have had similar things. It allows us to track changes and work with draft versions and roll forward and backwards. And there's been discussions about Git for data for 15, maybe longer years. We had a good look at what takes there are out there. And there's things like, the first are kind of variants of dropping files in a version control. So you have a SQL dump or you have a CSV file and you just commit it into your Git repo and that's it. But it's not a very helpful solution for data sets. You need to be really careful about how data gets in and out. And you just can't share it with anyone who isn't basically you. The second group are systems that have been inspired by Git and friends. But if you look at the spectacular achievements of the Git community with respect to software and the time and effort being applied in Git to solve large-scale problems with really large, complex repositories, there's an enormous amount of work to even begin to catch up to where Git is now. And then you have to keep putting in more and more work to try and keep up. Some of you might have remembered GeoGig, which was built originally by the Boundless team before they got acquired by Planet, and unfortunately isn't being developed anymore. GeoGig kind of fits into this inspired by Git camp. There's a few cloud-based systems using IPFS, but they're often academic projects which don't seem to be focused on solving anyone's practical day-to-day issues. People don't care about peer-to-peer networking when they can't figure out what their teammate changed last week in the data that's sitting in front of them. And there's a small group focused on managing models and data for machine learning. And lots of these are focused at software developers who have to deal with data, and very few focused at data practitioners who often have different wants and different skills and backgrounds. And so we've spent the last few years building Kart. We launched publicly in March 2020 at Git Merge, and we've been beavering away and making improvements since then. So what is Kart? It's built on Git because we focus on the data and the geo, and we can leverage other people focusing on the versioning. We want to maintain compatibility, so Kart should be familiar to every Git user, but it won't be identical. Our users have different needs, and we're dealing with data and not code. For example, so far we've chosen not to introduce a staging index. We want it to be easy to install with the batteries included across major operating systems. It doesn't interfere with what's in what else you've got installed. CRS handling works, database connections work. We're not a big data solution for people with 10 terabyte size tables. We're for the data sets you're using regularly and don't have bespoke tooling for, and don't have software engineers writing that bespoke tooling. You can start using Kart as one person, whether or not your team, organization, suppliers, or customers are. Kart's open source, and we want it to work just as well and powerfully for ArcGIS and AutoCAD users as it does for QGIS and PostGIS users. At Coordinates, we've acid tested Kart against tens of thousands of small and large data sets with many years of version history that we already maintain, and we have a shared interest with our customers and users in this being the best it can be. So let's jump into Kart and show you a little bit about what it can do. And I'm going to focus today on the PostGIS side. That's why they're here. And so what I'm going to do is swap to terminal. There we go. And so we're just going to start by cloning a Kart repo. Kind of worked. So we've got a file here, and we're going to do a little clone of this data set I prepared before. And so what does a Kart repo when I'm using a Postgres database look like? And we'll talk a little bit about working copies in a second, but you might recognize that we've got kind of a database URL here. So I've asked Kart to do is clone this repository and make my working copy a Postgres database, or put it into a Postgres database that already exists. So go into here, which is our repository, and we can see there's basically nothing here, but that's because our working copy's in Postgres. So what does that actually mean? Well, we can go and have a look. My Postgres database is just a random test data you might expect, but we have a schema. called demo Kart. And the demo Kart schema is looked after by Kart, and it has some data sets in it. And in this case, I've imported these data sets from some shapefiles. And we've got three data layers: building points, island polygons, and road center lines. And we can go and have a look at these data tables. They're just normal stuff. And the geometries are PostGIS geometries. They're just kind of normal. And we can just make changes because it's a SQL database. So we can do an update, and we can, in this case, say that we're going to make this road 2 lanes instead of 1. So we're going to update request. It's done update. If we go back to Kart now, we can ask for the status, and it says that we've made 4 changes to the road center lines dataset. We can do a diff. You can see that we've changed these 4 rows, and we've changed 1 attribute. We can do diffs in other formats too, because maybe you want to figure out more what's going on. We can get it in GeoJSON, and we can get full features and see what attributes are in the old and the new version of our change. And we can decide that we're happy with that. And we can commit those changes, just like we do with Git. And now we can see a log of the history in our repository. So this is the change I just made here. And it's got my name and my details. It's got a date. It's got a unique cache, which identifies that data set, or that exact combination of data. And there's our original input commit. And so we can see that this history of changes is kind of tracked there. Just gonna change to QGIS. QGIS has helpfully half switched to dark mode, so I'm not quite sure what's gonna happen here, but these are just PostGIS layers, right? So we can connect. And we can go into our Kart. Give me 1 second, and I'll see if I can turn off dark mode. There we go. So these are just normal PostGIS layers. We can add them in, we can view them on the map. Yet again, 100% of the time, QGIS puts layers in order I don't want. And we can go and make changes here too, because it's just the data set. And so one of the things we're going to do here is add, I'm just going to resize this a little bit. I'm going to add a new development to our island. This happens to be the Chatham Islands off the east coast of New Zealand. And so we're going to add some new houses and some new points, and then we're going to look at how branching and kind of other stuff works. So we will edit the layer in QGIS. We're going to zoom in. We're going to add some points. And then we're going to add a road. So edit this layer as well. We're going to take it from here and across the islands. And then give it a couple of lanes. And we'll give it a name. Wide lodges roads. We'll save our changes in both these layers. And now if we switch back to our PostGIS session. we can see that our changes are in the database. So of course they're here. We can switch to a different branch. Oops. Let's try that. And we can add 2 commits for our different buildings. Let's run from here. And that's great. We can see that we've got these changes here on a different branch from our main development branch. And we can switch back to main. Kart will go and update PostGIS again. And if we go back to QGIS, and hit refresh, then our kind of data is gone. And if we switch back to the other branch, we're kind of all there. So what we're going to talk about next is what sort of data is there and how does it kind of work under the hood. So vector and table data sets, we can do up to around 100 gig kind of table size, which is fairly good. And it's per data set, not per repository. We have a SQL model underneath for data types. And so when you get a working copy in different formats, which I'll talk about next, then the types are mapped back onto SQL-ish types. You can import data from Postgres and GeoPackages and shapefiles and OGR formats. And we support branching and merging and conflict resolution, and we support schema changes as well. Obviously, if you're making schema changes, you need to be a little bit careful and aware, but Kart fundamentally supports it. We also support point cloud datasets. This is kind of a PostGIS related, but we're also going to be adding rasters and other stuff too. And in those cases, the actual files live on something like S3, and Kart carries around the metadata about those tiles. So I mentioned working copies. Our demo showed Kart data being imported into a Kart repository, stored in Kart, and then Kart created a working copy, which is in our editable view of the repository data. And in our case, we created that in PostGIS. And right now you can use any of these formats. So GeoPackage, PostGIS, MS SQL and MySQL, and Esri file geodatabases are definitely on the roadmap as well. And so you can make different users can use different formats. So we can collaborate on the same repository with somebody using PostGIS, somebody else using file geodatabase, and somebody else using a GeoPackage. We have a QGIS plugin as well, and I'll quickly show that. So it's in the plugin. That was the previous talk from today. And we can see we've got our data sets here. From here, we can add things to the map. And we can see our history. In this case, we're now on the main branch. And if we switch branches here, or we can view diffs and other things kind of within QGIS. And the idea over time is that we can do that in ArcPro and in AutoCAD and other things too. So how does it work in PostGIS? So we saw before how Kart managed tables live in their own schema. This is Kart's schema, and it's separate from your other tables. So obviously you can use the Postgres search path mechanism to integrate them together. But one small catch with this is you can't just hand over your existing tables to Kart. Right now you need to import your table into Kart, and then Kart will give you back a working copy that's in its own schema and it manages it. You can obviously edit those tables, but Kart's kind of takes it upon itself to change the data when you ask it to. So changes are tracked by primary key and saved by triggers, and then Kart will connect to your repository and compare content in those changed rows. Obviously, if you have non-version data and you're forming relations to version data, you need to be a bit careful with referential integrity, because Postgres at the end of the day won't let your data break, but it also won't let Kart switch to a revision that removes rows that other tables depend on. If a repository is imported from a data source without a primary key, like a random shapefile, then Kart will add a PK for the purposes of populating it into Postgres to make sure it keeps working. We have another funky feature called spatial clones. And so what does this mean? When you get a national or a continental scale data set, but you actually only care about a particular neighborhood or city, why do you need to carry all that data about? With spatial filtering, we hide the irrelevant data from your working copy, and we don't even have to transfer it about over the network either. But crucially, you can do full editing and updating from the original source. So it's still part of the repository. We're just not displaying it or downloading it necessarily to your computer. So can you use it now? Yes, you can. We have customers building project systems and workflows on Kart, but there's a couple of really easy use cases that you can start exploring Kart with. The first case where your team works away at a new version of a data set, which is then published or released. And by publishing, I could mean internally, loading it into a different database, or publishing externally. So you're making a release. And the second is all these external data sets that you have in your system, stuff that's coming in from maybe government or your suppliers. You got administrative boundaries or classifications or lookup tables, data that can and should be updated regularly and tracked. You can put these in a Kart repository, easily explore the changes, and then access them reliably from your operational system databases without necessarily needing to go all in with Kart on that. So other stuff that's on our roadmap, we're building our ArcGIS Pro and FME plugins for those. Raster and grid data sets I mentioned. Improving archiving and exporting data from Kart repos so you can easily email that shapefile back to your client and just be the most organized person they've ever met. With respect to hosting, at the end of the day, a Kart repository is a Git repository. So you can use GitHub or a directory on a remote server for hosting Kart. Coordinates is building out dedicated Kart hosting service. So feel free to talk to us if you want to go further. And we're also working towards, over the longer term, interlinking data sets. So your view of the world probably doesn't match your data providers. So Kart will allow you to pull disparate data sets from disparate repositories together sanely into a versioned project repository. So your publisher, your data providers might have all sorts of data, and maybe they're updating. And then you're pulling a bunch of different data sets together into a single project repo. And we want to extend our coordinate system handling to allow you to naturally work with data that's in a different CRS from your source, all while still being able to synchronize your repo with new data as it's updated. And that's all I've got. So we get to hear some questions.
Yeah, I have I have questions. You talk about diffs, which is cool. And spatial diffs have been something which, have interested me for like 20 years. I was wondering what, if I have like a square and I move one edge of the square, but leave the rest of it intact. Like, what does my spatial diff look like? What does the diff look like? Does it say, oh, totally new square? Or does it say, look, the edge moved just a little bit over here?
So what I can do is show you what a spatial diff looks like. I'm going to go back up to this one. Sorry. And I think we can, let's just switch branches, sorry. Nope. I'm gonna, let's add my island onto a map. I was going to edit it if maybe it's easier. No enough. Zoom to that. I'm going to make some edits, and then I am going to see what it looks like. And then select that. And if I can figure out how Regis's editing tools work.
That's always fun.
Yeah.
How do you click the vertex? You got to click it just the right way.
Just the right way.
It's a nice little twist of the
Starting
wrist.
with- Yes, I think it's that one. And then you can move it.
There you go.
Okay,
You cause
so-
damage.
It's damaged now.
Yeah.
So we can show my working copy changes. And we can see that our geometry is different, and we can go and see that. So this is like a transparency view. So you can see the old and the new.
After.
And we can have different base maps. So your project layers, we can also do swipes. So you can like see that, hey, there's the old one and the new one. And how are they different? I'll get it down. So we're trying to explore some ways of like, how do you kind of do this stuff around being able to visually compare things. And I think we can do a per vertex diff. There's like a green and a red, so you can see different, which vertexes.
And then, but just from the point of view of internal storage, like it is like a whole new line string each time.
Yeah. So our maps onto effectively, you can think like of get object per row essentially from a process point of view.
So it's row-wise diff. So a question from Dan Harrell or Harold Dan. Does it handle any processing outputs? Does it handle any processing outputs, or is it just meant to be used as a manual editing changelog tool?
So I mean, the idea is that if you're creating, if you're editing your data using whatever you use, then it should be able to capture that. So one workflow that isn't super great at the moment is taking a bunch of files and producing a bunch more files from that, which is a lot of GIS workflows. So that's something we definitely want to capture. It's quite easy at the moment to say, hey, here's my shape files from before this change, and here's my shape files from after, or here's my, if you've got a workflow that takes in something and spits out something else. And obviously the working copy, if it's in PostGIS or a geo package, will reflect whatever changes in processing you do to it. So it tracks that stuff over time. Yeah. It's up to you to choose when to kind of commit those changes. Right.
So you're seeing a lot of people use this for like distributed data management?
Yeah. So, I mean, like one workflow we've had is teams working on things over like a long period of time where they're trying to like revise a plan and they've got different kind of streams of work around kind of finishing that, and they send releases out for consultation and everyone's kind of just keeping track of like what's there and what's the latest draft and who's given feedback on this, and using that sort of thing. And other people are starting to build it into different systems.
Chat question. So one repo by thematical layers to track equals one schema.
Yeah, so Kart manages one repo is basically one schema in our PostGIS model, and a repository can have multiple data sets in it. So, I mean, repositories are free, but data sets are free too. So if you want to logically progress a bunch of like individual data sets, then having them in a repository kind of makes sense if they're related, or they're logically related, if nothing else.
Okay.
Yeah.
Well, thank you very much, Robert. This has been a great talk and neat to learn about Kart. I hadn't known what the current state of the art in version management and geospatial is, and now I do.
Awesome. Thank you.
Enjoy Phosphor G UK.
Cheers.